In this section of our module, we're going to talk about RAM, Random Access Memory, System Memory, Main Memory. So RAM, which is Objective 1.3, we need to be able to compare and contrast the RAM types and the features. The RAM types include DDR, DDR2, DDR3, SDRAM, SODIMM, Rambus, and DIMM. Features are going to include parity versus non-parity, ECC versus non-ECC. Then we're going to talk about RAM configurations, and that's going to include single channel versus dual channel versus triple channel. We'll also talk about the difference between single-sided versus double-sided memory, and then we'll talk about RAM compatibility and RAM speed. Okay, so RAM, RAM, Random Access Memory. That's our system memory or main memory, and you might remember from the analogy I did a long time ago that is the desktop where you'd be sitting in your cubicle. Remember, my analogy was your brain is your processor. That nice empty desktop right in front of you is where you do all of your work. The filing cabinet over against the side wall of your cubicle is the permanent storage, and that's your hard disk drive. So, you come in and sit down in your cubicle, what's the first thing you do? Well, you open up that filing cabinet and you pull out the operating system, Windows, Linux, whatever it may be, and that is loaded into RAM. Your operating system boots into those main memory modules, and that's where it continues running until you shut down the operating system. You load an application. Maybe it's just a browser to go to eBay so you can bid, or you load a word processor or Excel spreadsheet or whatever. Those applications, they also run in this system memory, the main memory or the RAM. Anytime you need to modify data, that data is held in RAM so that the CPU can access the data, modify it, and then put it back into that RAM. What we're going to see when we do the hands-on are these RAM memory modules are inserted into slots on the memory board. We've already talked about some of the other features of that memory board, of that motherboard, and the RAM modules are plugged into the motherboard. And when we did some of our visual tours, I pointed out where those slots are for the memory or the RAM. First of all, let's look at the memory packages, sometimes referred to as modules or occasionally called sticks, memory sticks. One of the memory packages that you need to be aware of is the one that's most prevalent in the industry right now. That's the DIMM, Dual Inline Memory Module. That's the one you're going to see me plug into the 4 system motherboards of our computers. Your desktop, your tower PCs today, they all use these DIMM modules. So it's Dual Inline Memory Module. Another package is the SODIMM, and this time the SO simply stands for Small Outline, Dual Inline Memory Module. The SODIMM is used in a laptop computer because it is smaller. Obviously, its name implies that, small outline. Even smaller still is a micro DIMM. That's going to be used in the smaller laptops with less physical space. If there's a DIMM, which is the Dual Inline Memory Module, the old legacy memory modules that we used to have were called SIMMs, which was a single inline memory module. We'll show you a picture of those, but I don't have any computers that use the old SIMMs. We're talking 12, 15 years ago. All right, the packages, what we're going to see on the next couple of slides, are going to show you the pictures of what one of these might look like, but it's also going to identify the pin numbers, the count of how many pins. And yes, they may ask you that on the questions that you see on your exam. So be aware that it would behoove you to know some of these pin counts on some of these modules. Well, here's one of the old legacy memory modules that I talked about, and this is the SIMM, the Single Inline Memory Module, used a long time ago. And I've got pictures here of a couple of different of the old SIMMs. The two up at the top are 30-pin Single Inline Memory Modules, and then the two down below are 72-pin SIMMs. Again, you might see these in a museum, but probably not in any system you're going to run into today. Be aware of that acronym SIMM as the very old Single Inline Memory Module. DIMMs are the packages that we use now, Dual Inline Memory Modules. Now what I've got here is a picture of an SDRAM. It's a 168-pin memory module, and we're going to see this one more time. But this is one of the memory modules that you will see in systems that you work on nowadays. Let's get specific about some of these and we're going to nail down the acronyms and the pin count. So the SDRAM, SDRAM, RAM of course stands for Random Access Memory. The D stands for dynamic. And when we use the D for dynamic, that means that that memory module needs a refresh electrical signal on a very regular basis. The other side of the coin would be static memory. And we're going to talk about static a little bit later. But right now, the D stands for dynamic. Constantly needs to be refreshed electrically to keep it going. So, RAM, random access memory. D for dynamic, needs the electricity. And the S at the beginning of this, SDRAM, means synchronous or synchronized. What you now have is memory that is synchronized with the system clock. It's synchronized with what's called the front side bus, or the FSB. That is that system bus clock, and the front side bus is the connection between the processor and the memory. It's actually the connection between the processor that goes through that memory controller hub that you saw in the chipsets to the memory modules. But that front side bus speed and the memory modules are now synchronized together, kind of like a metronome. So what happens with this first memory module that we're talking about is it's synchronized. SDRAM is synchronous, dynamic, random access memory. The first of these synchronized, dynamic, random access memory was synchronized in a one-to-one basis. In other words, if your front side bus was going along click, 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 I make a pretty good metronome, don't I? Your memory was doing the same thing, right along with the front side bus clock speed. Now these first memory modules were called SDR, single data rate. The single data rate is a one-to-one. The single data rate, SDRAM, means it's single data rate, that's the SDR, synchronous dynamic random access memory. I know it's a boatload of acronyms, but you need to start with the concept of understanding that that first SDRAM, synchronous dynamic RAM, was a single data rate, and it matched with that front side bus. The picture that we're looking at right here for that first SDR memory was the 168-pin memory module. One thing about that memory module that would be helpful is it has two notches. Two notches on the underside down there where those gold pins are. That means it's going to fit into a motherboard where the memory slot actually has two little pieces of plastic sticking up, and the memory module would fit down over those pieces of plastic to match the notches. That's good for two reasons. First of all, it means you can't put the memory module in the wrong way. You have to turn it correctly so that the two notches match the slot. And I'm going to show you that physically at the end of our presentation. Secondly, you can't put one of these SDR, single data rate, SDRAM, synchronous dynamic random access memory. You can't put one of these in a motherboard that's not made for that module. SDRAM, or single data rate, synchronous dynamic random access memory, is a 168-pin memory module, and it has two notches. DDR stands for double data rate. Double data rate, we're going to talk about in more detail later, but instead of a one-to-one basis, what you've got is the system clock is still going one at a time, but the memory module is doing double. Boom, 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 boom. Now we're going to get a lot more detail of DDR, so just hang on to that concept and we'll give you more details later. But here's what the DDR memory module has. 184 pins. It has a single notch, or sometimes referred to as a key. That key in this particular case is a little bit closer to the end of the module as related to the other DDRs. So this is the first DDR at 184 pin memory module. The next revision of that family was the DDR2. This one came out about the year of 2003. DDR2 is a different memory module. It's 240 pin. It also has a single notch, but this time the single notch is a little bit closer to the middle as related to its cousin, the original DDR. That means that you can't put the memory in the wrong place. You can't take a DDR memory module and put it into a motherboard that's made for DDR2. DDR2 is 240 pins, and DDR3 is also 240 pin. So here's a DDR3. It came out around the year about 2007. This notch is a little bit more off-center compared to its cousin, the DDR2. Now, I suppose you're wondering, how do we keep them all straight as far as plugging them into the right motherboard in the right slots? Well, one of the things that's kind of nice about this is the notches on all of those DDR memory modules are not the same. Between DDR, DDR2, and DDR3, the notches have been moved, and you can see by this little comparison chart here, so that you can't actually put any one of those memory modules into the wrong motherboard. Kind of handy. But you need to know those pin counts. They may ask you that on the exam.